Okay, so in this module, we're going to expand the reactions that we know beyond the double displacement and single displacement reactions that we did before. So same thing, we're going to be writing net ionic equations, and hopefully you've seen these in CP. I believe everybody has. So we're going to go through them pretty quickly, but I'll make some points that hopefully you find helpful. So we're going to start with reactions that are decomposition reactions that produce gases. They're kind of special classes of compounds, but they always produce gases, and they're kind of unique about how they result in their net ionic equation. So we're going to be focusing on chlorate decompositions, carbonates, and hydroxides. There isn't a lot that you need to memorize in AP Chem, but these three, you do need to know these classes of compounds and the products they produce, because they show up a lot. Okay, so let's go to the next slide, and hopefully I can go to the next slide. We're going to get rid of me because I want to show you a lot of stuff here. So we're going to start our first group with chlorates. So all chlorates decompose in the same way. And what I mean by chlorates is anything that has the chlorate ion in it, like sodium chlorate, or for instance, magnesium chlorate, or potassium chlorate. Anything that has a chlorate, it doesn't matter how many chlorates it has, because if you check charges, there might be more than one, but they definitely have chlorates. Okay, so how do you predict the products of these things? Well, it's important to understand that all of these are usually powders. They're solids. All of them are solids, because this does not work if you're about to do them in water, because you're going to take these solids and you're going to heat them at very high temperatures. Matter of fact, this one is the only one that in this list that most high school classrooms can do, because the others require even higher temperatures than a Bunsen burner. But what happens to them is every single time you do a chlorate, you will get the salt that results from the front of it. So like for instance, magnesium chloride here. Now of course I need to check the charges on these two. Mg's +2, chloride's -1, so that needs a 2. But you'll get the salt, so that's one thing you'll get. So down here I'll get KCl. But then it will also produce oxygen gas. Now all of the decomposing products we're going to talk about today, which I told you are chlorates, carbonates, and hydroxides, produce some gas. This one produces oxygen. Okay? Now sometimes when people are doing chlorates, they get it wrong because they remember that it makes some sort of gas, and they write CO2. But if you look at it, you know you can't make CO2 gas here because there's no carbon, right? That's a chlorine, so you can't make CO2. But all three gases in the classes of compounds, I mean here you get oxygen, but all three gases are a very common type of gas. For instance, carbon dioxide or water can be a gas, right? So you're going to see in all three, there's some everyday easy to remember gas. The hard part is this other part. And so in this part, you make the binary salt. Binary means two, as in there's two ions in it. You make the binary salt that's whatever the kind of the front of this thing is. Now, if we were going to write the net ionic equations for these three, we're done. Right? The reason we're done is because this is a solid. You heated it and produced an ionic solid and a gas. There's nothing aqueous in here. So these are the net ionic equations. There's nothing to dissociate because there was never any water at all. We are done. These are so easy in that respect. Okay? Now, I want you to have a visual of it because this can be a hard thing for people to understand. So I'm going to show you somebody else's video of the decomposition of potassium chlorate. If I can click through and get the video going.
But
all right.
This reaction we're going to do today involves...
So I actually don't know if I'm talking over him or not, but that's potassium chlorate. So I'm going to stop this right here. You're going to notice potassium chlorate is a white solid. And most ionic substances are solids. Actually, they all are, right? So if it's ionic, as in it has positives and negatives in it, there's another one that's ionic. And if there's no water around, they're always going to be crystalline solids. So that's why you don't need to look up aqueous solubility rules. I mean, if you're like, wait a minute, but this is a 1A element and that's a 1A element, why are they not aqueous? It's because there was never any water in there at all. It doesn't work if you add water. At least this reaction doesn't work. So he's going to take this potassium chlorate and he's going to heat it strongly. Now I told you the other ones, they wouldn't work on this little tiny Bunsen burner he has at home. But this one will. And you can imagine what's going to happen. We're not going to see a whole bunch. We're going to see maybe a little bit less solid in the end as it becomes potassium chloride. but that's also a white powder, so we're not going to see anything. But a whole bunch of oxygen is going to start filling this test tube. So the test tube in here is going to become pure oxygen gas above it. And that's pretty darn cool. Now let me see if I can get my cursor back. I don't know if I can. I'm having troubles getting my cursor back. But he's going to do a second reaction here. Because the tube becomes filled with oxygen gas, you can test for oxygen gas by doing what we call a flint test. So you see that piece of wood he's got is a flint. If you put it in there in oxygen, it should get way brighter. And watch this. So the second part at the end is not really the decomposition. It's a combustion reaction, but watch what happens when wood combusts in pure oxygen. It's crazy. Watch, it's going to get going. He's having to heat it a little bit to get it started, but once it gets going, he won't have to heat it. Look at that. Look at that. Craziness. And the reason that combustion was so vigorous is because the test tube was filled with pure oxygen. So the other thing I wanted you to get out of this, other than the fact of what this looks like, we're talking about solids here, that we're heating and we're getting solids, and we're making pure oxygen. And pure oxygen can be tested with the flint test. It will ignite a flint and make it a little bit glow, a little bit brighter if you do a little bit. But yeah, crazy. And I will tell you, I cannot believe he's doing this in his house. All right, let's go on to the next slide here, if I can. So that's what a spontaneous decomposer looks like. And that's why the net ionic equations are so simple, because there is no water at all. Let's look at carbonates. So obviously these are things that have carbonate ions in them. So if you were going to predict the products, you know it's going to make some obvious everyday gas over here. And it's not going to be oxygen this time, it's going to be CO2 gas. Which I think makes sense because you can see there's a lot of carbon and oxygen in there. CO2 gas is the gas that you breathe out of your mouth, right? And if you think about it, this gas, when it gets created in this reaction, will it be flammable in the flint test? What do you think? No. The reason is, think about that, that'd be crazy. You breathe this out. If you breathe this out and it was flammable in the flint test, it would be so dangerous to smoke in a shower. Well, I guess it's dangerous to smoke in a shower anyway, but no, what it does is it puts the fire out, right? So you could do a flint test here, and if you had CO2, it would just extinguish the fire. So they all make CO2 as a gas. Now the front part is they make their metal, that's the metal, that's the metal, and that's the metal. They make the metal oxide. So KO, CuO. And at this point, we need to check charges. Na's plus 1, O's minus 2, boom. K's plus 1, O's minus 2, boom. Cu, we don't know here, but carbonate's minus 2, so I think that's plus 2. So I'm going to say plus 2, minus 2, boom, there we go. And of course, these are all ionic solids. How do I know? They have metals and nonmetals. And there's no water around, just like the previous one, we're heating dry powders. And since you have ionic compounds with no water, they're always solids. And the same thing's going to happen. Now, I'm not going to show you this one because it's kind of lame, right? As in, if you heated this thing, it would make a white powder from a white powder, and you'd fill the test tube with CO2. And if you put a flaming stick in there, you're not going to get any fire. It's just going to put it out. So that's what the flint test for CO2 would do. Okay? So we've had chlorates. Do you remember what gas chlorates make? They make oxygen, and carbonates make CO2. The tricky part is chlorates will make the binary salt in the front, whereas carbonates will make the oxide, right? So that's the major difference. Now we got one more class of these decomposers that require a lot of heat left, and that is the hydroxides. So let's look at the hydroxides. Okay, so hydroxides are any compound that has hydroxide ion in it. On the right side, right? It doesn't matter how many. All of these also require a ton of heat and doesn't work if you have water around. So they're all going to be solids. So if you're like, well, wait a minute, that's a 1A element. Remember, there's no water around at all, so there's no chance of it being aqueous. Here, what gas do we get? Well, this one might not seem like a gas. We get water. I mean, element-wise, it makes sense because there's a lot of H's and O's over there, right? But we get water. Why is it a gas? Because you're heating it at very high temperatures. So the three gases you're going to get are O2, CO2, and water, right? This one comes from chlorates, this one comes from carbonates, that one comes from hydroxides. The rest you can probably figure out. Just like with the carbonates, you get the metal, oxide. Metal is nickel here, oxide. Metal's potassium here, oxide. And then I just have to check charges. I think this one being a transition metal, let's go. That's -1, there's 2 of them, so I think that's +2, +2, -2, it's good to go. +1, -2, boom, there we go. And, of course, all of these never had any water. All of these compounds are ionic, so they've got to be solids. So same thing, you'd have a white powder, heated, you'll get a white powder, and then you have a whole bunch of water vapor coming off. So again, if you were to take that flaming flint and stick it in there, nope, it would put out that flint because it's only oxygen that burns strongly, right? So that's the trick to all this. Know that they all make a common gas. You just have to remember which one. All of these, by the way, if you want to remember, are gases you breathe in or out. And here, mostly out, but you breathe a little water in too. They're things that you breathe, everyday common gases. Okay, so you know the three classes of hydroxides, chlorates, and carbonates. Now go to the assignment, and I want you to practice this because it's just a little bit of sort of muscle memory, and you'll get really good at it.